Howdy, y'all. Good morning. How are y'all doing? Welcome to another fabulous episode of How Many Tabs Are Open on Mr. Johnson's Computer, Thursday, March 25th edition. We have 3 tabs, no trace. And we have 2 assignments today, well, 1 assignment and 1 math quiz. Definitely do the assignment before the math quiz, because most of the time the assignments make the math quiz easier because they go over the same topic. And you have a video for the assignment. So don't forget, well, you're watching the video. So we're going to take a look at today's activity. All right. So it's a tables and graphs kind of day, I'm sure. Let's find out what we're looking at. Oh, if it ever decides to load. All right, we can look like we have green check marks. So on the assignment on Monday, or Monday or Tuesday, there was one about moving green check marks. Don't forget to remove the green check marks. It's an important part of this assignment. So if you did not move the green check marks on your assignment earlier this week, it's probably sitting there as incomplete. So go back and move the green check marks and resubmit your assignment. All right. So what you're going to do here is, first off, read the instructions, move the check marks, click to move the check marks, right? So if you don't click to move the check marks, you will not receive full credit for the assignment. All right. Click to move the check marks to the correct pattern and rule that is represented by the table. As you can see, your table today looks more like your 2nd grade, 3rd grade, 4th grade table. They are basically like, instead of giving you the table, they're almost giving you the input-output machine thing that you used to see on your countdown to star warm-ups and stuff like that. So what we're going to do is we're going to find out, is this a additive rule or a multiplicative rule? And then after we figure out if it's an additive rule or a multiplicative rule, we're going to figure out what the actual rule is. All right, so once again, I'm going to go ahead and try and work this side by side, because I believe that that will help us to see everything all at once. So it might look a little small, but we'll get through it. Okay, so what we're going to look at to begin with is, I'm going to transfer the information from their like 2nd grade, 3rd grade looking table, and I'm just going to make a 5th grade table. All right, so they have labeled in and out. In 5th grade, what are we using instead of input? X. And what are we using instead of output? Y. All right, so you have your X and Y, or your in and out. All right, so on the first part, their first X was 4 and 5/10. Remember, if you're saying 4.5, you're saying the number, but you're not saying the value. It's 4 and 5/10. All right, 4.5 does not help you when you're on a test, because like no answer in the multiple choice section will say 4.5 in words. If they're looking for word form, it'll say 4 and 5/10. All right, so don't forget that. If you're saying point, let's go ahead and move on to saying like hundredths or tenths or whatever the decimal is. 1 decimal place means tenths. So this is 5 and 5/10, and their output was 11. And then finally we had 6 and 5/10 with an output of 13. So what we're going to have to do first is we're going to have to figure out, what are my 2 rules, right? For this first line, I'm going to make an additive rule and a multiplicative rule. Because I'm trying to spell out a vocabulary word, I'm going to zoom out. Multiplicative. All right. So I'm going to make my additive rule and my multiplicative rule. All right. And I'm just going to make the old school, like 2nd grade, 3rd grade, 4th grade rule, and then we'll turn it into a 5th grade rule at the end. All right. So if I'm trying to turn 4 and 5/10 into 9, what can I do? Well, if you don't know the difference between 9 and 4 and 5/10, you can always subtract to find the difference. So if we're trying to find out what we add to 4 and 5/10 to get 9, we could subtract 4 and 5/10 from 9 to find out. So let's go ahead and borrow. So 10 minus 5 is 5, 8 minus 4 is 4. Drop the decimal point like it's hot. So it looks like this was add 4 and 5/10. All right. Now, if we're trying to figure out how we would get this with multiplication, right, we could divide, okay? But we also know something about 4 and 5/10 2 times equaled 9, right? If we subtracted 4 and 5/10 to get 4 and 5/10, that means 4 and 5/10 plus 4 and 5/10 equals 9, which means that 4 and 5/10 times 2 also equals 9, right? If we want to check that work, 4 and 5/10 times 2. 2 times 5 is 10. 2 times 4 is 8, plus 1 is 9. All right, one decimal place, one decimal place. So it checks out. 4 and 5/10 times 2 is 9. You might be saying, but there's a 0 right there. Remember, with a decimal point and then a 0, it's the same value. It's 9 and 0 tenths, which is 9. If you had $9.00, you have $9. All right, so now we can go ahead. We've got some rules that check out. Let's go ahead and use those rules to figure out if we're going to drop our pin. We're going to use those rules to find out which one checks out. Which one checks out for our table. So first thing we're going to do is we're going to check out both rules. We're going to add 4 and 5/10 to 5 and 5/10 and see if that equals 11. And then we'll multiply 5 and 5/10 times 2 and see if that equals 11. So we're going to find out whether this is an additive rule or a multiplicative rule. So I'm going to carry my 1, and that gives me 10. 5 plus 4 plus 1 is 10. Drop that decimal point like it's hot since we're adding. So does 5 and 5/10 plus 4 and 5/10 equal 11? No, it equals 10. All right, let's try 5 and 5/10 times 2. 2 times 5 is 10. Carry the 1. 2 times 5 is 10. Plus 1 is 11. One decimal place, one decimal place. That looks like the same number. So plus 4 and 5/10 is not going to work with that one. Times 2 did work with that one. So since it worked with the first two pieces of data right there and right there, let's go ahead and just multiply 6 and 5/10 times 2. If that equals 13, we have our rule. So 2 times 5 is 10. Carry the 1. 2 times 6 is 12. Plus 1 is 13. One decimal place. One decimal place. So 6 and 5/10 times 2 is 13. So our rule worked with times 2. Now remember, times 2 is not your 5th grade rule. With 5th grade, it has to be basically 2x, which means x times 2, right? There's 2 x's. You have 2 groups of x equals y. Whatever your input letter is what we did. We multiplied our input letter times 2. So x times 2. Once again, if you write x times 2, that looks really confusing. So instead of writing x times 2, they simplify the whole thing by just writing 2x because it means the same thing. Saying x times 2 is the same thing as saying 2 groups of x. When you first learned to multiply, you realized it was repeated addition or groups of. So 2 groups of 2 is, or 2 groups of x is the same thing as saying x times 2. So we have a rule, 2x equals y. Because the equal sign can just means both sides are the same, we can also flip it. It does not matter which side we put it on as long as the correct piece is by itself. Y, the output, is forever alone. It's by itself, all right? And then x has a friend. Okay, x has a friend to add with, x has a friend, and they can multiply. So y is just by itself. Okay, so y is equal to 2 x's. Anything that we put in our input side is our x. And if we double that, multiply it times 2, we will get our y every single time. So it is a, I gotta find my mouse. There we go. It is a multiplicative rule. So we're going to move the green check. Remember, this is a huge part of your assignment. Move the green check to multiplicative, and then we're going to actually move the green check to our rule, which was our multiplicative rule. Y is equal to 2x. Okay? So basically what we've done there is we have turned our information into a 5th grade table. We tested rules. We found an additive rule that worked for the first line, a multiplicative rule that worked for the first line, and then we tried it for the rest. So we got 3 more pages, and it looks like 2 more pages have the old school table and 2 pages have your 5th grade tables. So let's go ahead and work through it. Ooh, they brought fractions into this one. All right, so remember, input, output, it's the same thing as x and y. All right, So they have 3 and 1/4, 4. 4 and 1/4, 5. 5 and 1/4, 6. All right. On this one, this pattern should be easier to see. We started with something that's like below the y. Our x is less than 1 below our y. 3 and 1/4. So let's imagine money. 3 and 1/4 is like $3.25. $3.25. They sometimes call a fourth a quarter. All right. So you have 3 and a quarter, and you're getting to 4. That means you're 3/4 away. All right. So 3/4 are 75 hundredths. Okay. And what I mean by that is if you have a dollar in quarters, right? 3 out of 4 of those is worth 75 cents or 75 hundredths. So 3/4 is equal to 75 hundredths. So if you play back and forth in your head when you have quarters in fractions and think about it like money, that can kind of help you. Because if I see this as money, I'm like 3.25. How much money do I need to make $4? I need 75 cents, which is adding 3/4 of a dollar, right? The second one, if I have $4.25, how much do I need to make $5? I need to add 75 cents, which is 3/4 of a dollar. I'm using these fractions instead of the decimal because all of my numbers in my x column are fractions. All right. The next one, 5 and 1/4. That's like having $5.25, right? 5 and a quarter. So $5.25. If you wanted $6, you would add 75 cents. Remember, 75 cents is the same thing as 3/4 of a dollar. So on this one, we didn't even have to like really try our multiplication one because the pattern, you could kind of see it was the same every time. 3 and 1/4 moved up to 4. 4 and 1/4 moved up to 5. 5 and 1/4 moved up to 6. So we saw every time we just added about a fraction to get to our answer. We figured out that fraction was 3/4. 3/4 plus 1/4 makes 1 whole, right? If we did 3/4 plus 1/4, you get 4/4. And remember, 4/4 is the same as 1 whole. Okay? So, knowing that, we found our rule already, and that's cool. Thank you, fractions. Fractions helped us out this time. So, plus 3/4. Okay? So, we're going to go ahead and let's find our rule with the check. And our rule is over here. Ooh, I clicked on the wrong page. Sorry. So, we had x plus, oops, that's the eraser, x plus 3/4 equals y. And that's because we took our x and we added 3/4 and got y. Every single time we took our x, added 3/4, that gave us our y. We took our x, we added 3/4, and that gave us our y. So our rule is x plus 3/4 equals y. And we have y equals x plus 3/4 over here. Remember, because the equal sign just means both sides are the same, you can flip-flop the sides, and it can say something like this. It does not change anything about the problem by flip-flopping which side of the equal sign they are on. All right? Okay, so that is an additive pattern. Let's go on to the next page. And now we are given our tables that we should be comfortable with at this point because we are 5th graders. We are almost 6th graders. This is insane. Y'all are growing up so fast. Can't believe this year is almost over. 1 more 9 weeks. That's nuts. Okay, so let us find out. We got to find out a rule. All right, and on these, all right, I know that I did it the hard way for the first two. On these, you could also just look at the rules and decide which one works. All right. So I know some of y'all were probably already thinking that, like, why is he figuring out the rule? I want you to know how to find out the rule because they're not always going to give you a multiple choice rule to pick from. Sometimes they're just like, here's a table, tell me the rule. Like your quiz might have some of those questions. So what we can do is we're going to try either plus 24 or times 3. We know that because it says over here, y equals x plus 24, y equals 3x. Remember, 3x is 3 times x. So let's figure out on all of these which works, plus 24 or times 3. All right, so let's start with the first one, 12 plus 24. That's 36. That does work. So far, so good. All right, let's try 12 times 3. 12 times 3. Oh. Oops, I don't know why I put that there. 3 times 2 is 6. 3 times 1 is 3. That also equals 36. Okay, so, both of these work. We have to try another one. So let's try our next set of data. All right, so we're going to try 14 plus 24. So we're going to do our additive rule first. So our additive rule, 24 plus 14. 2 plus 1 is 3. Oh, that makes 38. So that suggests that 14 times 3 is probably going to give us 42. 3 times 4 is 12, carry the 1. 3 times 1 is 3, plus 1 is, 3 times 1 is 3, plus 1 is 4. I don't know why I'm having trouble multiplying this morning, but hey, it happens. All right, so we have 14 turns into 40, 14 times 3 turns into 42. So 24, add 24 did not work, times 3 did work. So let's go ahead and try our last one, 16 times 3, since we're pretty sure that times 3 is going to work. 3 times 6 is 18. 3 times 1 is 3, plus 1 is 4, 48. Look at that, 16 times 3 equals 48. That one's good. 24 plus 24 does not work. So it looks like out of the rules that we have the times 3 rule. Now remember, as a 5th grader, your times 3 rule will be y equals, and if you're doing multiplication, it's the amount that you're multiplying times x. All right, so 3x times 3, that's x times 3, just turns into 3x. So x times 3 is the same thing as 3x. This looks confusing, so let's not use this. This is pretty easy. 3 groups of x. All right, so on our sheet, we're going to move over our check mark to the y equals 3x rule. And then we're going to move it back over to multiplicative because it's a multiplicative rule. We multiplied times 3. We took our x numbers, multiplied them times 3, and that gave us our y numbers. Okay, I want you to go ahead, try this one on your own. Pause the video, stop the video, whatever. And then after you're done, check your work with the video because I want to just see if we're doing all right with this. So give yourself an attempt. If you want to do it like the super like challenging way, don't even look at the rules before trying to figure it out. If you just want to like see if you're doing all right, look at the rules and just find out which rule works. Does the multiplying times 2.5 or 2 5/10 work, or does adding 2 5/10 to each number work? So I'm going to go ahead and start on that. So if you could just pause the video and check it out whenever you're done. So welcome back. Here we go. Here's your input and output, right? So input we had 5, output we had 7 5/10. Input we had 7, output we had 9 5/10. Input we had 9, and then output we had 11 5/10. So according to our rules, we could have either been adding 2 5/10 to all of these, or we could have been multiplying times 2 5/10 for all of these. And I know that because when I'm looking at the rules over here, it says x plus 2 5/10, which would be these numbers plus 2 5/10, or it says y equals 2 5/10 x, which means we would take these, the x numbers, and multiply them times 2 5/10. Okay, so let's find out which ones work. So if we take 5, right, and then we add 2 5/10. Remember, it's going to be a little funky. Emoji 0 makes it less funky. All right, so now it looks like 0/10 plus 5/10. That's 5/10. 5 plus 2 is 7. And then drop it like it's hot. 7 5/10. That does work. Awesome. So let's test 5 times 2 5/10. All right, now what you might have noticed is I put the 5 and then it almost looked like the 5 was going to go on top. You can't do that. All right, don't do that. You always have to put the number with the most digits on top. All right, the number with the most digits goes on top. And in fact, I'm going to erase this and rewrite it because I'm going to be out of room if I carry. So the number with the most digits goes on top. 2 5/10 has more digits than 5. Don't add an emoji 0 to multiply, because what you're going to do is give yourself an extra step that you don't need to do. All right. So you can multiply a whole number times a decimal number like this. Just make sure that the number with the most digits goes on top, because then you can do your regular multiplication. So this is basically like, ignore the decimal point once that's set. And it's basically like 5 times 25 until the end. 5 times 5, 25. 5 times 2, 10, 11, 12. So we get 125, but we have one decimal place. So we need one decimal place in our answer. So 7 and 5/10. 5 times 2 and 5/10. So when we did this rule, it did not work. All right, because 5 times 2 and 5/10 equaled 12 and 5/10. So we'll check one more with our rule. All right, what I want to do is I want to check and make sure that 7 plus 2 and 5/10 equals 9 and 5/10. If so, I'm going to be pretty confident that we found the rule. All right, remember, it looks funky like that. If you add an emoji 0, it's a little easier to look at. 0 plus 5 is 5. 7 plus 2 is 9. Drop it like it's hot. So 7 does indeed turn into 9 and 5/10 when we add 2 and 5/10. So add 2 and 5/10 worked there, and then just for posterity's sake, I'm going to go ahead and do it one more time with our last piece of information. 0 plus 5 is 5. 9 plus 2 is 11. Drop it like it's hot. 11 and 5/10. So once again, addition worked. Multiplication didn't work on any of those. So they gave us a really bad rule to test out with our multiplication. It didn't work with our first line, our second line, or our third line. So what kind of rule was it? Well, it looks like what we're doing is we're taking our x value and adding 2 and 5/10. Let's take our x value and add 2 and 5/10. And then the pattern, because we were adding, comes out to additive. All right, so that is all 4 pages. I hope that you had success with these. I hope they are becoming easier. I hope that seeing the old school input-output tables made you feel nostalgic for the land of old, when y'all didn't have to worry about X and Y. But now you can kind of see that connection of what you were learning when you were little to what you're learning now. And that's just basically how math works. The things that you learn today will be important, not only this year, but in 6th grade, 7th grade, and 8th grade. So as you can see, the things that you learned in 3rd grade and 4th grade help you in 5th grade, just like the things you learn in 5th grade will help you in the future. All right, I've taken enough of your time. Thank you for watching. I hope you have a wonderful day. Like and subscribe if you feel like it. Talk to your teachers if you have questions. And I'll see you later. Have a good day. Bye.